In this video, let's take a very quick look at a new concept called arrays. In the previous video, you might remember that I had a bunch of points where I had an x and a y, and I had to list them all out, and it was kind of annoying. So if I wanted to do, for instance, a points, I would have to list out point 0 and then give it an x, and then I'd have to do point 1 and give it an x, and point 2 and give it an x, and so on and so forth. And it was a little bit annoying to write, and I had to do the same thing with the y values as well. And in any case where we might have a bunch of different things that we're going to have to keep using, then it becomes a little annoying to type this all out. And on top of that, if we don't know exactly how many things we're going to have in advance, then we probably need some way to be able to figure that out and store a bunch of stuff. And so the way we can do that is with an array. And the way I would describe an array is it's like a list of things. So here I'm going to create an array, at least in theory. Well, we're going to take a look at it. And this array is going to represent the x points from what I just did there. And so what I can do is kind of store them all right next to each other and then be able to look them up based off of what number they are. One thing to consider is in computer science, we always start counting at the number 0, not at the number 1. So the first entry in this will always be 0, and then everything after that will be just a normal counting number. Another thing to consider about this is that the length of this is 5. And so the last element is always going to be the length of our array minus 1. So here if I have 5 elements, because we start counting at 0, the last one is going to be at position 5. And this will become important later as we try to figure things out. Now, if I wanted to do what I was doing earlier, I could simply store all of my variables in each of these. So 4.7, 8.6, negative 2.1, 4.3, whatever values I want to throw into here, I can throw them all into. Whatever value I want, I can just throw them all in here. And being able to set these and being able to use them is actually quite easy and doesn't require us to make a bunch of different variable names. So first off, the way we declare an array is we give the type first, similar to how we do normal variable declarations that we're used to. So here, let's just say all the numbers in this array are all floats. And then I give the name of the array that I want, x, and then after that I use these square braces. So I'm just going to use these square braces to designate that I want an array. And one thing that you need to do when we're doing arrays like this, at least static arrays, which is what we're going to cover here, is you need to give it the length that you want. So here the length we said was 5, right? And so what this line of code does is it creates this array. It creates a list of things where they're numbered, so they're indexed. They go from 0 to 4, and so I'm going to be able to store 5 things in them. And so if I want to access any of them, all I have to do is use my array again and give it the square braces. So here, if I wanted to set this element to be 4.7, I simply put the name of my array, which is point x, and then I put 0 because I want the 0th element, and I want it to be 4.7. If I wanted to set the first element, it would be element 1, which would be 8.6 here, and I could keep going for the rest of these as well, 4, 2, 3, and 4. And so really this is just a way for us to be able to throw a bunch of things, be able to kind of number them and have them all stored together, which is very convenient if we know we're going to be doing something a lot and we know we're going to use things that are similar. One limitation to this, at least doing it this way, is the fact that we always are going to have to keep the array the same size. So if you do a static array like this, the only kind we'll cover in this class are static arrays, then once you give it a size, that's it. It can't change for the rest of the program. Some compilers will do this in different ways, but generally when you're creating arrays, you want this to be a constant or a literal, just meaning you physically write down the number. We don't want to have an integer variable and then plug it in for this, because it does do something a little different, and it's something that we don't really want to do in this class yet because it involves memory management, and I think that's a little beyond the scope of this course. Right, so that would cover static arrays for the most part. Just remember, this makes an array of size 5. Right, so it's always the size or the length of it is going to be that thing there. And then we can index it. Maybe I should use a different color for that. We can index it by simply using a number to go into the thing and look up what is in that location. So here, index 0 is 4.7. One error you might see that we could possibly do here is what would happen if I try to index something that's not in the array. So here, let's go off to the side and do something bad. Let's say I try to get .x 7. Now, this is going to be bad. This isn't going to work. One thing that is unfortunate is that the compiler cannot always catch the fact that you are going to do this. Especially if you're using a variable to access the array, then we're not going to be able to use it in that way, and it's going to cause your program to crash. So consider, if I try to access 7, this array ends at 4, and so the 5, the 6, and the 7 are just kind of here floating in space. They exist to the right of where our array actually is. Now, because we're doing a computer, there is actually stuff over there. Again, consider that everything is stored in memory. It's like RAM, right? And so if you try to access a 5th or a 6th or a 7th element, it's probably there as far as reality goes, but it's not stuff you want to be dealing with. So here, let me just throw in a last value. Anything that's in this area is probably just garbage. And it's completely unusable, and you will more than likely get a runtime error if you try to go outside of it. And so I would like to mention this because it is a common error that you might occur or notice. It's called a segmentation fault or a seg fault. If you ever see this when you're running a program and you get this error, it means that you're trying to access something outside of where you're allowed to access. Usually this is for an array, and so that's why I mention it. Make sure you're always checking what variables you're using to be able to access the array. Lastly here, let's just go over how we could maybe access all of the elements of this array if we wanted to print them. So let's just say I want to print the 0th element, and then the 1st element, and then the 2nd, and 3rd, and 4th. And so hopefully you're thinking, oh, well, if I'm counting, then I definitely need to use a loop, and you would be right. Let's use a for loop really quick to go through all of the elements in this .x array. And so one way we can do this, remember, if we count, is we can just say for int I equals 0, and I'm going to pretty much always use 0 from now on. Even if you're used to 1, then I think it's a good idea to do 0 here, because consider, again, all of our arrays are going to start at 0. And then the next thing that we do is we say, well, we want to go while I is less than, and we want to stop at the end of the array, right? We just said if we go out of bounds and go too far to the right, then that's bad. So we're going to avoid that. One way we can do this is with the length function. Depending on the compiler, it may be different. I believe length generally works in C++. If not, we'll discuss some other methods as well. I++. And I'm just going to print these elements. So I'm going to put one single statement here, and it's going to see out .x. And then remember, the way that we access elements from an array, this list kind of thing, is we do these square braces, and we just put the number. In this case, since we're counting with I, if I put I in here, then it will access every single element. And so if I actually was to go and run this, what we would see, right, is that this loop is going to happen a few different times. So first things first, it's going to figure out, well, the length of point x, the array, is 5. So it's going to say, okay, that contains 5 things. And then it's going to say, well, all right, I'm going to start I equal to 0, and I'm going to go while I is less than 5. So the first loop, it's going to do it while I is 0. The second loop, it's going to do it while I is 1. And in the third loop, it'll do it when I is 2, 3, and 4. And once it does the last I++, because that just adds to it, right? That's why it's been counting up this time, is once it gets to 5, 5 is not less than 5, and so it breaks. And so the thing to notice here is that if we count this way, where we start at 0 and go up to the length, is that it will always start at 0 and always end at the number that comes before length, which we said would be length minus 1, because we know that the last element is always at length minus 1 in an array. And so this, I would say definitely memorize it, remember this. This is how you go through an array pretty easily if you want to be able to go through all the elements. You start at 0, and you go until you're less than the length, because once you hit the length, you want to break because the length goes out of bounds. And so this here would print all of the elements that are inside the array that we described above. It's a pretty basic overview of arrays. In the next video, we're going to do an example where we actually use it in a program, and then we will see how it works.